Steps for simplifying RVEs. So our goal in this lesson is to actually simplify RVEs. One thing you need to remember is that you need to factor both the numerator and denominator. At this point, once you have the denominator, especially in factored form, we can state all the restrictions on the variables. And then from there, all we're going to do is reduce the rational variable expression. And when you're reducing, what you're looking for are common factors in the numerator and the denominator that you can cancel out. Just as a little note, you must state all restrictions before you reduce. And the reason for that is because after you reduce, some of your restrictions will get reduced away, but there are still restrictions because they're based on the original problem, not the simplified problem. So, when you simplify a rational variable expression, the simplified statement has exactly the same value as the original expression. Therefore, the reduced or simplified expression must have the same restrictions as the original expression. Okay? So, we do need to state the restrictions right at the beginning before we start reducing things away. Example 2 looks at simplifying and stating all restrictions. So we're going to follow the steps. The first step was to factor both the numerator and denominator, so that's what we're going to do. So factoring is a big part of this part of the unit. So in the numerator, I see a common factor of 2, and so I have x minus 5 left. In the denominator, we actually factored this earlier. It was a simple trinomial. And so I remember that the product was a negative 35 and the sum was 2, and the two numbers were 7 and negative 5. So the denominator factors to x plus 7 and x minus 5. And at this point, because the denominator is in factored form, I can state the restrictions. So when you say your restrictions, add a little comma after the expression, and then write down what variable you're stating restrictions on. And then based on the restrictions in the denominator, we can just state them. Remember to try to write it in numerical order from lowest to highest. So in terms of the first set of brackets, the value of x that would make this set of brackets equal to 0 is negative 7. So negative 7 is one of my restrictions. And the value of x that will make the second set of brackets equal to 0 is x equal to 5. So that's my second restriction. So negative 7 and positive 5 are my two restrictions. Okay, so x cannot equal negative 7 and 5. Now from here, now that I have everything in factored form, I've stated my restrictions. All I'm going to do is look for common factors in the numerator and denominator. And what you'll notice is that x minus 5 is a common factor in both the numerator and denominator. So this reduces to leave me with 2 over x plus 7. And again, I'm going to restate my restrictions. And essentially what you'll notice is you're going to restate your restrictions in every step. Okay, so there's an example of a simplified rational variable expression with the restrictions included. Okay, you will notice that x equals negative 7 is still a restriction here, but 5 is the one that's been reduced away. But because it's dependent on the original expression, you still need to make sure you write it. Okay, let's take a look at the next example. So in this case, you'll notice that everything is already in factored form. You already see the product of each of the parts of the term. So negative 6 is multiplying with x, which is multiplying with y, and negative 18 is multiplying with x, which is multiplying with y. So because everything is in terms of products, we already have this in factored form. So what we're going to do is look at the denominator and state the restrictions. So here, because I have three terms, negative 18, x, and y, I know that negative 18 will never give me a result of 0, but x equal to 0 will give me a denominator of 0, and y equal to 0 will give me a denominator of 0. So what this tells me is x and y cannot equal to 0. From here, it's just a matter of reducing things away. So negative 6 divided by negative 18, that would reduce to 1 over 3. So negative 6 over 18 reduces to 1/3, and the negatives will cancel each other out. In terms of your x variables, I have 2 x's in the numerator, 3 in the denominator, which means I'll be left with 1 in the denominator. And in terms of the y variables, I have 3 in the numerator and only 1 in the denominator, which means I'd be left with y squared in the numerator. And again, I'm going to restate my restrictions, just like I had in the previous step. And you'll notice again here, there is no y equal to 0. There's no y in the denominator anymore, but the restrictions are based on the original problem. Okay, here's a couple more examples. Again, we're simplifying and stating our restrictions. And so the first thing we need to do is factor the numerator and denominator. And what you'll notice is this time you have some complex trinomials. So I'm going to factor one of them on the side, and that just to remind you how to factor a complex trinomial, and then we'll go with it from there. So I'll just show you down here. So if you have 6a squared minus 13a plus 6, which is what we have in the numerator. Remember that this is a complex trinomial because you have a coefficient in front of the a squared term that's not equal to 1. So we need to look for a product that's equal to 6 times 6, which is 36, and a sum that's equal to negative 13. And so I know the two numbers will be negative because the product is positive and the sum is negative. So I know the two numbers will be negative 9 and negative 4. So from here, you break up the middle term into two parts. So minus 9a and minus 4a plus 6. And then you factor by grouping the terms. So I'm going to look at the first two terms and look for a common factor, which is 3a. And I'm left with 2a minus 3. And then I'll look at the last two terms and I'll factor out minus 2 and be left with 2a minus 3 as well. And if these two brackets are not the same, then that means either you factored it incorrectly or the two numbers you chose were not correct. And so what I'm left with is 2a minus 3 multiplied with 3a minus 2. Okay, so back to the problem. We factored the numerator and we got 2a minus 3 and 3a minus 2 as my two factors. In the denominator, similarly, if you factor it as a complex trinomial, you will get two factors again, and those two factors would be 4a plus 3 and 2a minus 3. Okay, so in this case, I have everything in factored form. I need to look at the denominator and figure out which values of a will make each factor equal to 0. And what you'll notice is that a is my variable. And if I look at the first set of brackets, the value of a that'll make this set of brackets equal to 0 is negative 3/4. And again, if you need to see how I'm doing that, I'm trying to figure out what value of a will make the denominator equal to 0. And so I'm going to isolate a. And I get a cannot equal negative 3/4. So in case you're wondering how I got that value of a. Similarly, in this case, a cannot equal 3/2. And so in numerical order, I have negative 3/4 and I have 3/2. Now, I've stated the restrictions. If there are any factors that are common in the numerator and denominator, I can reduce them away. And so I have 2a minus 3 and 2a minus 3, which are both common in the numerator and denominator. And so I'm left with 3a minus 2 over 4a plus 3 as the reduced form of the rational variable expression. But you'll notice that the restrictions are still the same. A cannot equal negative 3/4 or 3/2. Okay, and there's a restriction that's still there. That's the restriction that was reduced away. Okay, the last example. What you'll notice in this case is that it looks pretty easy, but there's one little trick in here that you need to pay attention to. Notice that in the numerator I have 4x minus 8, but in the denominator I have 4 minus 2x. The order of my variables is sort of backwards in the denominator. So the first thing I'm going to do is switch the order so that it follows the same pattern as the numerator. So the x term and then the number term. So I'm not doing any factoring here. I'm just rearranging the expression here. So I get negative 2x and then positive 4. So in this case, what I'm going to do is factor the numerator and denominator just like I've been doing all along. So I have a common factor of 4 in the numerator, and I have a common factor of negative 2 in the denominator. And now that the numerator and denominator are in factored form, I notice I have two factors here. One of the factors are negative 2, the other factor is x minus 2. And negative 2 can never give me a result of 0. However, x equal to positive 2 will make the second factor equal to 0. So x cannot equal to 2, otherwise you'll get a denominator of 0. Now if I simplify this, I have 4 and negative 2 that I'm dividing out. So 4 divided by negative 2 is equal to negative 2. And you'll notice that the x minus 2 here and the x minus 2 here actually cancel out. So what that means is all I'm left with is negative 2. So this expression ended up resulting in a very nice answer where it's equal to negative 2. However, the restriction that we had earlier is still there. Okay, remember that this restriction is based on the original problem. You need to continue to write it down. And that's it.